All right, good morning, class. This is Mr. Walker here, and we are talking about operations with proportions. This is the last thing that you have before the final page. This final page is just you running through practice between all the different types of fractions and solving equations that we have done as we go through these. So we're going to talk about this in a separate video. Then we will be with these proportions here. Okay? Now, one aspect of solving equations with fractions is dealing with proportions. A proportion is a fraction that is equal to another one. In order to solve these, you are going to need to cross multiply the two fractions and then engage in solving it as you would any other equation. Remember to follow the steps as we've talked about in previous slides. So, the basic method of us solving any given proportion is we have one fraction over here and it is equal to another one over here. In order for us to solve it, we have to multiply the numerator of one fraction to the denominator of the other, and the denominator of one fraction to the numerator of the other. So it just becomes a cross multiply right here and by here. Multiply just right across what that situation is. Now after you cross multiply, you have the numerator and the denominator of one fraction on one side of the equal sign, and the numerator and denominator of that other fraction over here. And then once you do, you go through and solve this like you would any other one to two step or multi-step equation. So you make sure that you simplify both sides. If you have like terms that you need to combine, you would combine them. And then you would move all your variables to one side, all your constants to the other. So in this case, we just have 15 and x over here. There's nothing more that we really need to simplify on this side. I have 6 times 20. That gives me 120. And I need to divide both sides here by this number that's with x. So when I divide both sides by 15, I get x by itself, and on the other side, I get 8. So on this page here, we're going to look at 4 simpler problems, and then we are going to look at number 16 together, because number 16 is kind of a doozy. So let's take a look at each of our problems here. First problem we are going to take a look at is number 1, and we are going to also look at number 5 right after. So starting off, we're going to just go through and solve this like how the example above shows us. So over here I have 10 over 8, and it is equal to n over 10. Now, if both of these two fractions are equal to each other, that means that when I go through and find whatever n is, well, these fractions can either be reduced down to the same fraction, or they can turn into the same decimal. So we're going to make sure that that works out after we go through and do this multiplication. And let's try it out. So for this first one right here, we got to multiply across from the numerator to the denominator of the other one. So I have to multiply 10 times 10 and n times 8. So the way this looks now, after I cross multiplied, is on one side of my equal sign, I have 8 and I have n. On the other side, I have 10 times 10. So now that I got this here, I need to make sure that I go through and simplify anything that I have on those sides. On this side, I can't simplify this anymore. It's just 8 times n, or 8n. On the other side now, I can multiply 10 times 10. So if I multiply 10 times 10, we know that is going to give us 100. On the other side, though, we have 8n. So let's go through, and we're going to have to make sure that we go and divide 8n, 8 by both sides. So now I'm dividing this side by 8 and this side by 8. So 8 divided by 8, those cancel each other out, leaving us with just n. On the other side, now I have 100 divided by 8. So if you want to check that out in your calculator, you can go through and do that. So I have 100 divided by 8. That gives me 12.5. So we have 12.5. Now, when I go through and do this, this is my solution. We got to make sure we check it. So always just go through, check your answer. So down here, we're going to go through, we're just going to check what we got, because we always have to make sure that these equations have the correct solutions. So over here, I have 10 over 8. On the other side, I have, instead of n, 12.5, and that's over 10. Now, there's two ways you can go about solving this. You could go and reduce both of these fractions down to the same number, or you can go through and divide both these fractions and turn them both into decimals. What I like to do is turn them both into decimals. Sorry, I got the hiccups. So let's go turn these both into decimals. If I go through and do 10 and I divide that by 8, that gives me 1.25. Now we're going to try that with the other one. If I do 12.5 divided by 10, I end up also getting 1.25. So, and I'm getting the same fraction, so that means that my solution here works and they are equal at the end of it. So that is our first one done. So make sure you cross multiply and then you can go through and solve it. Now, in some cases, what you could do is you can go through and reduce whatever you have in terms of your answers, and you can go through and see what the relationship is between your two fractions. In the next example, we're going to see that come into play a little bit. So let's take a look at number 5. So this time, number 5 has us going through, and we have 4 over 3, and it is equal to 8 over x. So just like before, we can go through and cross multiply and solve for what we have. So if I cross multiply what I have, this ends up giving me 4 times x, and that is equal to 8 times 3. So now you need to make sure you can simplify this. So let's go through and simplify. So 4 times x, that's just 4x. 8 times 3 gives me 24. Now I need to go through and get 4 away from x. So that means I'm going to have to divide both sides by 4. If I go through and do that, that gives me x by itself over here because these two cancel each other out. On the other side, I have 24 divided by 4. That gives me a 6. Now, this is one method that we can use to solve something like this. Another method we could do is taking a look at both fractions that we have and seeing what relationships happen between both numerators and both denominators. So let's look at that method because that might be a little easier in some situations. So let's look at both of our fractions we got here. On one side I got 8 over x. On the other side I have 4 over 3. Now, both of these fractions are equal to each other when they're both reduced. If they're both equal to each other when they're both reduced, that means that I am dividing whatever's over here to equal something that is equal to over here when I divide it. So, first we got to double check over here, see if we can reduce this. Now, if I look at 4 and 3, there's nothing I can divide both of them by, so that means that this is reduced in simplest terms. Now over here, we know that we don't know what x is, but we do know what 8 is. So let's take a look at the relationship between 4 and 8. So let's zoom in on here a little bit. All right. So I know that when I go through and reduce whatever is over here, I can get 4 over 3. So what that really tells me is that if I take 8, let's actually use a different color. if I take 8 and I divide it by some number, I end up with 4. Now, simple division, we do know that whatever this is going to give us this. So that's going to just be a 2. Let's use a different color. 2. Ooh, that's thick. Let's get that out of there. Don't want that. All right, 2. Bang. So this is the case for this. This 2 that we're reducing by has to work between x and 3. So let's look and see if that works. So I know x is being divided by that same 2, and that ends up giving us a 3. Now, if that's the case for that math right here, what we're going to need to do is we are going to need to go through the inverse of what's happening here. So if that's the case, that lets us know that x is equal to 3 times 2. And 3 times 2 is just 6. So that means that x is equal to 6 now. And so giving us the same math as we did over here on the previous one. So far so good. Let's go take a quick break, and when we come back with the next video, we're going to go through and end up looking at a little more complicated one.